Now let us see what is this canonical and standard forms. Wow. So throughout these canonical and standard forms, we'll come across some terms like literal, product term, sum term, min term, and max term. Let us see what is a literal. Literal already we have seen any variable or its complement is called as a literal, and product term is connected with and symbol, and sum term is connected with or symbol. And what is a min term? A product term in which all the variables appear exactly once, either complemented or uncomplemented form. So any product term if we take, in that product term every literal appears only one time, okay, and they might be in a complemented form or else in a uncomplemented form. And max term, a sum term in which all the variables appear exactly once, either complemented or uncomplemented form. So this is similar to the min term, but the only difference is it is a sum term, but whereas a min term is a product term. Okay. Now let us see what is a min term. Represents exactly one combination in the truth table. So it is going to represent one of the combination in the truth table, denoted by m suffix j, where j is the decimal equivalent of the min term's corresponding binary combination, that is b suffix j. So mj is the min term which corresponds to the binary combination, that is bj. We'll see with an example. A variable in mj, so it is a product term, mj is a product term here. A variable in mj is complemented if its value in bj is 0, otherwise is uncomplemented. So here mj is a product term, and product term contains variables. They might be in a complemented form or else in a uncomplemented form. So if any variable is containing in this product term, if any variable is containing 0, then it is represented with complemented form, and if any variable in this product term containing 1, then it is represented with uncomplemented form. Let us see an example. Assume three variables a, b, c, and j equals to 3. Okay. Now then bj equals to 0, 1, 1, which is the binary combination of 3, and its corresponding min term is denoted by mj equals a complement bc. As I told you that this is a product term, and in this product term if any variable is containing 0, now here a is containing 0, b is containing 1, and c is containing 1. Therefore a is represented as a complement form, and the other two variables are represented in a uncomplemented form, right? So min term is a product term, and in this product term will represent a variable with complement when it contains 0, and will represent the variables in uncomplemented form when it contains a non-zero value, that is 1. Now what is a max term? As I told you that it is similar to the min term, but here it is nothing but a sum term. But there is one more difference. Let us see what is that. Denoted by mj, which is a capital MJ here, okay, where j is the decimal equivalent of the max term's corresponding binary combination bj. A variable in mj is complemented if its value in bj is 1. Okay, so max term is a sum term, and if any variable in this max term containing a value 1, then it is represented with complement form, and the other variables are represented with the uncomplemented form. Okay, let us take an example. We have took the same example 0, 1, 1, and its corresponding max term is denoted by mj equals a plus b complement plus c complement. Why? Because b and c are the variables, they are holding ones. So max term is nothing but a sum term, and the variables inside the max term are represented with complement form if they contain logic 1. Okay, and the variables are represented with uncomplement form if they are holding a value, that is 0. Right? Now this is the truth table notation for min terms and max terms. Min terms and max terms are easy to denote using a truth table. So let us see an example. Assume three variables x, y, z. So as you have three variables, definitely you will be getting 8 combinations, starts from 0 to 7. Okay, and min term, as I told you that now this complete function, or as this complete input variables are represented with a single min term, that is with a product term, that is x complement y complement z complement. Why? Because x, y, and z are holding zeros, and they are represented with a complement form, so it is called as m0. This 0 indicates the decimal representation of this combination. Okay, and maxterm. When it comes to maxterm here, maxterms are represented with the help of sum terms. That is, it includes the operator plus. Okay, so x plus y plus z. Why? Because all these three variables are holding 0, so that is why they are represented with uncomplemented form, and the representation is capital M 0. 0 indicates the decimal representation of this particular combination. So in the same way, all the other minterms as well as the maxterms of this function are represented here. If you can see the last one, x, y, z. Why? Because all the three variables are holding logic ones. They are represented with uncomplemented form, and the minterm representation is small m, and the 7 is the suffix. And if you can see this maxterm, all these variables are represented with the complemented form. Why? Because all these three variables are holding logic ones, and the representation is capital M and the suffix 7. Now what is a canonical form? So any function in the Boolean algebra can be represented with the help of two canonical forms. One is sum of minterms and the other one is sum of maxterms. Okay, so canonical sum of minterms or else and canonical product of sums. Okay, sum of minterms or sum of maxterms, sorry, product of maxterms. Okay, so the other name is sum of products or product of sums, right? So any function in the Boolean algebra is represented in two forms: canonical sum of products and canonical product of sums. Okay, so now what is this canonical sum of products? The minterms included are those mj such that function equals to 1 in row j of the truth table for function. Okay, so canonical sum of products includes those minterms which produces the output as 1. Okay, canonical sum of products includes those minterms or those product terms whose output of the function is 1. And canonical product of sums includes those maxterms, okay, whose output function is 0. Let us see an example. Okay, so here f1 is a function with input variables a, b, c at right. The canonical sum of products form for f1 is, you can see the truth table here for a, b, c, that is the function f1. Okay, and this is what the output. Okay, now here sum of products. So sum of products, that is canonical sum of products, includes those minterms whose output function is 1. In the sense, the output function, the output for the function f1 is 1 here, as well as 1 here, as well as 1 here, and their combinations are 1, 2, 4 and 6. Now these four combinations are represented with the minterms form, that is m1, m2, m4 and m6, right? In the same way, canonical product, observe that, if you can observe that mj, that is minterms, are quite the complement of the maxterms. Okay, they are the complement of the maxterms. So if you complement these minterms, okay, or as the sum of product terms, then you'll get the product of sums. If you complement this product of sums, then you'll get the sum of products, right? Now the shorthand representation for sum of products as well as sum of products as well as product of sums. Okay, now we use this symbol, that is sigma symbol, for representing, or summation symbol for representing the sum of products. Okay, and we use the pi symbol for representing the product of sums. So summation m of 1, 2, 4, 6, where summation indicates that this is a sum of products form, and m of 1, 2, 4, 6 indicates that the minterms to be included are m1, m2, m4 and m6. Okay, so since mj equals to mj complement for any j, so summation m of 1, 2, 4, 6 equals pi capital M of 0, 3, 5, 7, where equals to f1 of a, b, c. Okay, so sum of products are represented with summation symbol, as well as the product of sums are represented with the pi symbol. In the next session, we'll discuss about the conversions between canonical and standard forms. Thank you.